Hi everyone! In this video we will solve exponential equations using natural logs. Solve, round the answer to the nearest tenth. 6 times e to the 4x equals 17. We're looking for solving for the variable, but the variable's inside the exponent, so our goal is to bring it down and isolate it. But before we bring it down, let's go ahead and simplify it to isolate it just a little bit by dividing both sides by 6. This leaves us with e to the 4x equals 17, 6. Now we have two ways to solve this. We can either rewrite or we can solve with the one-to-one property. On the left side, I'm going to choose to rewrite using the definition of logarithm. And on the right side, I'm going to choose to do the one-to-one property. On the left side, let's review the definition of a logarithm. If I have b to the x equals n, this can be rewritten as a logarithm as log base, and in this case the base is b, of the number that it equals the exponent, in this case x. And we can do that with our equation by rewriting it with log, and in this case our base is e, and log base e is the natural log, so we're going to change that to the ln, and there's the implied e down here. And then we have of the number, and the number is on the left or on the right side, the opposite side of the e. So we have 17, 6, and this equals the exponent, which is 4x. Then to continue solving for the variable, we'll divide both sides by 4. And now we're all done. We have x equals the ln of 17, 6 divided by 4. And we'll just type that into our calculator. On the right side, we can use the one-to-one property. This says if I have a number such as m that equals n, that I can do the same thing to both sides, just like we did with adding, subtracting, multiplying, or dividing, and it will keep the equal sign the same. In this case, I can take a log of both sides, and as long as it has the same base, log base b of m will equal log base b of n. In this case, the base that we're going to choose, because we are working with the natural number e, will be the log base e, which is the natural log of the natural log. So we'll take the natural log of both sides. So we have ln of e to the 4x equals the ln of 17, 6. And I'll put the 17, 6 in parentheses, making sure that both of them are inside the logarithm. Now on the left side, we're going to employ some of the rules that we learned. In fact, this one right here is the power rule, which means we can roll it down in front, giving us 4 times x times the ln of e, which brings our exponent out, or our variable, out of the exponent, and thus will help us solve our exponential equation. So we have the ln of 17, 6, there we go. On the left side, we have the ln of e. Because the base and the number match, there's the implied e here. To evaluate this, the answer from the inverse property is the exponent. There's nothing up here, which means there is an implied 1. So the ln of e evaluates to 1. And 1 times 4x is just 4x. So we get 4x equals the ln of 17, 6. Now to continue isolating the variable, we'll divide both sides by 4, which gives us x equals the ln of 17, 6 divided by 4. And we can see that it's the exact same no matter which way we solve it. We can either rewrite using the definition or use the one-to-one property. So now to type this into our calculator, because we've been asked to round this to the nearest tenth, we'll go to, for a TI-84, on the bottom left, you'll move up 3 buttons and you'll see the ln. So we'll type in ln and it will open a parenthesis and type 17, divide by 6, and then close the parenthesis because that's when the logarithm ends. Then divide by 4 and then press enter in your calculator and we get 0.2603. And we can stop there because we were asked to round to the nearest tenth. We'll look to the number to the right. 6 is greater than 5, so it rounds the 2 up to a 3, making this 0.3. And now we're all done.